one thing they don't tell you about this stuff here, or they don't make it very clear, they tell you that we're used to seeing y equals, what's the equation we have there?
Y equals 2x plus 3.
They're used to saying that y equals 2x plus 3, right? But they forget to mention that y is the same thing as f of x and y. They're exactly the same thing. Because all f of x means is that the x value in here, the function y is a function of the value of x. So y is whatever x tells it it is. And the thing they also don't make clear is that the y value is actually range, and the x value is actually domain. Now, that doesn't even make sense. That doesn't make sense to me either. So let's talk about that for 1 second so it makes sense to you. Over here. What that means is that if I had a graph like that, the range here is all the values here and here, and the domain is all the values here and here. So domain is the x, range is the y. That's all domain range is, right? They make it sound really, that's just because math people like themselves seem really not really important, so they use words like range and domain instead of x and y. That's whatever. Who cares? So if I had a function like you have right there, y equals 2x plus 3. So let's just have a look at that for a second. Break it down. Alright, so if I had that as my equation, I'm going to have my x value here and my y value over here. So you have how many x values do you have? Just one?
Yep.
What I'm going to show you is that if I use whatever x value I use, let's say I use x is 0, 1, 2, 3, for example. If my x is 0, 1, 2, 3, my y value, according to this equation, is going to be the corresponding, so whatever it is that value here is, it's going to have the corresponding value up here. So if I have 0, which means I will put a 0 in for here, 2 times 0 is 0, plus 3, which means over here I'll have a 3. What that means to us in the graph here, it means that if I have the x value of 0, which would be right here, the corresponding y value would be right here at 3. As the x moves to 1, I'll take that dot, for example. If I use the same dot, this dot moves over here to 1. Now the value goes to 1 times 2 is 2, plus 3. Corresponding dot goes to 5. 1, 2, 3, 4, 5. Here. See what I mean? It's 5. So for every time I move this across here, oops, move one more time. Now it's 2. Changes up here to a 2. Now it becomes 2 times 2 is 4, plus 3 gives me a 7. 1, 2, 3, 4, 5, 6, 7. And what you start noticing as we go along, this, funnily enough, turns into a straight line. And that's basically a linear function. But what I'm pointing it in here is that for every value of x, I'm trying to show you, oops, my bad. every value of x, there is a corresponding value of y. But then what they do, they change it. They say, okay, f of x equals 2x plus 3. So it looks way different than over there, but it's really the same thing. So if I were to put 3 in here, I would say, what is the value f of 3? What that means is that all we're looking for is the value right here. I move this over here to 3. Oops. I move the same dot over here to 3. Come over that to here to 3. What number will be in the graph up here? And we can watch before we even do this. Watch this. It will be 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will be 9. It'll be right there on the graph. But let's put the number in and double check. That's what happens. We put a 2 in here. 2 times 3 plus 3 gives us 6 plus 3 is 9, which also falls on that graph. So when I give you a number like that there, f of x is 11 or x is 11, all they're asking you to do is take that number, put it in for x, and solve the equation. That's all I want you to do.
Alright.
That make sense?
Yeah. That makes way more sense than still what the teacher was teaching it like.
That's the range is y, domain is x. That's all I'm going about. So for every x value, I can keep coming over. See if I come over to this one, watch this. If I put it with that right here, oops, my bad. Put a dot right here. This is green. Put a dot right here. There'll be another corresponding value of x right there and the range. This would be the domain x. The range would be up there. Make sense?
Mm-hmm.
And that's what domain and range is all about.
That's simple enough.
Not bad, eh? What else we doing?
Everything else with this unit is pretty much good, I think, honestly. So I'm just double checking.
You doing factoring?
Factoring, yeah. Here's
Let me
more
see how you
like
do
domains and range stuff too. Written out in that way.
Alright. So, just let me see that again. I'm write down what that means. And it took me a long time to be able to do this. These squiggly lines. Years of practice. Watch this. This is an X in
Yeah, X with that slash
X.
and then minus. I forget what that means. That's something for domain, she said.
It might be -1, I think.
No, I erased that there because I had a wrong thing written in.
What's that there?
That's XER at the end of it for like the domain ER. I forget what the ER is. I think it's written here or it's on the front cover. Here's how she said we should always write it domain range for that. And these are either equivalent or like non-equivalent if they have underlines on them. Like these would be equivalent then.
Yeah, shit, don't worry about that. That's bullshit.
All right.
I ain't worried about this. Let's look at this for here, for example. I'll make up a number. I'm going to put the EXE in there. It doesn't matter. Make sure it's not crap anyway. The important piece is right in here. That's the important part. If I were to take that there, put that on a graph. Right? What that means on the graph, this domain on that graph means that the x value, right, because it's a domain, means it falls on this line right there. Which means that this function is fine as long as the x value is greater than -1, so right here, -1, and less than 3. 1, 2, 3. Now there's two ways that they show you in the books. Some books say if it's less than, if it's greater than -1, what they do, sometimes they will use an open dot, like this. Sometimes they will use an open dot. it means it's greater than, x is greater than -1. And if it's over here less than, they would use another open dot. Like this. And your domain is right there. In that section there, that's the domain. Sometimes if it's not that, and that open dots, if they do equals, this would be a closed dot. And if they don't use open and closed dots, sometimes what they do in some books, what they use is this stuff here. If it's oops, not that. If it's less than, they would do this. Less than, they would put a curved line and -1. And if it's negative and +3, a curved line like that. But if it was equal to, they would use a box like that. So the square means equal to, curve means not equal to, or just greater than or less than. That's how it says there. So and then your range would be y is -1 to 9. So that would be your y range.
-1 to 4.
Okay. So your y would be range on your y would be -1. Be right here. Is that less than or less than? Greater than. Okay.
Yeah.
So it'll be curved line. And 4 would be 1, 2, 3, 4. Oops, I'm shaking. That'd be your domain. So basically, your function would lie within these boundaries here. That all means is that the whole function would lie inside these boundaries here. That's all that means.
All right.
Make sense?
Mm-hmm.
Excuse me. Do this one, for example. This one here. If I were to do that, what's the equation for that one?
It doesn't say. It's just.
Well, okay, let's just look at it, for example. If we want to look at the domain and range, the range would be, which is the y, since these go on forever, right? The range would be x or y would be less than 5 to infinity, negative infinity. I don't know. That would be your range. Your domain would be across this way, and would be this goes out and keeps on going out. Going out would be negative infinity to positive infinity. So when you're talking about domain, it's this way. Range is this way. Here, for example, domain here would be greater than x is greater than 0, because it's this side of the graph only. And the range would be positive infinity, negative infinity. Your y values, right? This will keep going on forever. And your total y values would just be positive and negative infinity. Here, for example, your range would be, that's one, whatever there is, that's just your range right there. One number. Do y equal to whatever that number there is, because it's your y value. And your domain would be from this number here to this number here, the x values. So x is distance across this way, and domain, x or domain is distance across this way, range is distance up and down that way. That's all you worry about.
Alright, I can see that.
So let's look at this one here. What would be your domain on that one?
2.
Equal to or greater than?
Greater. Not equal to.
Not equal to because it's open dot, right?
Oh, yeah, right, greater.
So it'll be greater than because the domain is going this way, right? So your domain would be x, all x's greater than 2, which goes on forever, right? How about your range, which means up and down this way?
0. No. Yeah.
Y. How many values in the y is it there? Is it down here at all?
No.
But it's up here, right?
Yeah.
It's going to keep coming all the way out this way. So y is going to be always greater than 0. You understand?
Okay, yeah.
Because it starts here, which is 0 on the y-axis. So it's always going to be greater than, never going to go down here. It's always going to be greater than this number here. So my y value here, this would be, if I were to put a point here, this would be x equals 2, y equals 0. So 0 at y is going to always be greater than 0. Never less than. And that's your range would be y is greater than 0.
Bex.
Hey, your name is beer doesn't mean drink it. Does that make sense? No, it doesn't make sense. Let me know. I'll get different ways to explain all the shit. Different ways.
It makes sense to me.
Let's look at this one here. This one's kind of tricky a little bit. What's the domain on that one? Domain means x. Which the domain on that would be? Are they dots or points?
Points.
Points?
Yeah, they're points.
And they're arrows. See the arrow?
Mm-hmm.
Arrow means it goes on forever. If it was a dot, it means it stops. Let's look at it for a second that way. What I'm going to do, I'm going to show you this graph right here. I'm going to make this up as we go. So what I'm going to do here, I'm going to do a graph for you, like this. Actually, yeah, this one here. And it's out here. I'm going to go here. Right? So you notice in this line I'm just drew here, I'm going to put a dot here and a dot here. Now you see that with a dot means that's where it ends. So the domain on that is what? What's this number back here? 1, 2, 3, 4, 5. It's a shaped in dot, which means it's going to be negative 5. So x has to be greater than or equal to negative 5, right? But over here, it's going to be 1, 2, 3, 4, 5. And also less than or equal to 5. See that? What that means is that the x values will only go from here to here. That's all it means. That's the domain. The range in this one will go from here. This is going to be, see, this is negative 2. The range would start at negative 2, less than or greater than or equal to y, which is less than or equal to 1, 2, 3, 4, 5, 6. That's going to be 6. That's your range, because it's the distance on this line here. It's the distance right here, from here to here. This is your range, and this is your domain in the green. That's all I look for. Looking for this one here. Now if I put arrows in here instead, what happens now? This is going to go on forever this way and forever this way, which means it's going to be infinity, positive and negative infinity on the y, and positive and negative infinity on the x. So that's what you domain range in that case. But with no arrows, it terminates, and you're good to go. Make sense?
Mm-hmm.
Awesome. You're getting the hang of it now. Good for the report. That's all it means is x's and y's, and so limits of x's and y.
That's just one thing that I wasn't really completely sure on when it was coming down to this type method with this here, the XER, then that stuff.
I mean, what you mean. I forget what that means anyway. Don't work that really crap. For example, here, the domain here would be the distance from here to here. The range would be the distance from here to here. That's it. That's all I got to worry about. Make it sound really confusing, but it's not that confusing. That's what math teachers do, because they don't understand themselves half the time, I don't think. But I didn't say that loud because I'm actually recording what I'm saying. Don't do it to your teacher. Alright, so how about something else? Anything else you're working on?
Don't need to worry about that stuff. I understand what's a function and what's not a function with the lines very well. That's
not draw a line straight through. When checks twice is not a function, once is a function, right?
Mm-hmm.
Right.
And same with the linear lines too. I get that stuff as well. I think that's it for this.
How about okay
for this, it seems.
Have you done any factoring of polynomials?
I think that's in one of these here. I think we have done this one.
So that's where you get into GCF, like greatest common factor and least common multiple.
Yeah, that was in this one.
Alright.
We get to that and least common as well in that one. This it's just by the linear functions and systems of equations, which I get the systems of equations like slope, rise over run, that stuff, and the
That's
y2. Oh yeah, the linear, my bad. And the y2 minus y1 x, like that stuff.
You
I
understand
get
where
as
it
well.
comes from? What works?
Oh yeah, no,
Alright,
I know how that works. I forget it is something in here that I'm not sure about. I can't remember what. I think I'm actually good with this unit though. Yeah, no, I think I'm actually good with this full unit like this.
What's happening here?
For this one, it's just like AX, you put that down first, then BY, you put that down, and then what's left over, then you gotta get that behind that one to get X away from the Y by itself.
What are you doing here with this one?
You pretty much just find the slope of it, then you gotta get Y by itself, so what happens then, from what we said, was just subtract 4 here, put at the end of there, so 4x then goes at the end of there behind the equal sign. Divide it out by 3 to get Y by itself then, because then that cancels. And then 12 by 3, you get 4, and then that negative 1.
Then you just roll and make sure it's up here.
And then that's the answer there
Yeah.
for Y. For like that I also get too. And just, yeah, this down here I understand as well. The x-intercept and y-intercept. And the slope, once again, that's nothing. That's something that I usually understand. Same with the y equals mx plus b.
Mm-hmm.
Yeah, not pretty much this whole unit
Okay.
here I understand yet. So that one's not worrying about. There was 6n squared plus 3n plus 9.
So let's forget about the GFC, what's the
GCF.
Yeah, whatever, who cares? 6n, I don't do math by the book, I do it the easy way. 6n squared minus 3n
Yep. No, plus 3n.
plus 3n
Plus 9.
plus 9. So instead of worrying about GCFs, what I'm going to worry about more is what number can you divide into that, and into that evenly?
3.
Is it? It's GCF. That's all you worry about. So then I'm going to take 3 out of there. I'm going to factor it, for example. Take 3 out. I'm left with 3. 6 divided by 3 is 2n squared plus n plus 3.
Yeah, it's basically the one that's just
So it's just find out what can go into this, and this evenly works and goes into each 3, goes in all 3 of them. And if you try a different number and if something else works, then keep going with that. So don't have to worry about GCFs at all. Let's do another one.
I think the miss had us there one was like some of this 6 goes into like 18, 12 or something. 6r, then you like times that into those to get that done.
Alright, this is 8 minus 18 squared, isn't it?
Yeah. Minus 18r squared plus 12r. She had us doing just like
Okay. Now let's look at this. I want you to worry about is one main thing. What number can you tell me that you can divide into that and into that?
6.
6, right? So what I'm going to do, let's do it piece by piece, the way I would do it. I was showing you. So 6, let's take the 6 out here. Oops. Put some brackets in there. So we'll get 18 divided by 6 is?
6.
Oh,
oh, excuse me.
3, right?
3, yeah.
R squared plus 12 divided by 6 is?
3.
2.
2.
No worries. Right? That's fine. Everything's cool, right? So when I look at this again, oops, back that way. So now I'm looking at this closer and say, okay, what else? It's common here and common here. The R's are, right?
Yeah.
So there's an R here, 2 R's here, and there's 1 R here. So let's take the arrow outside. So I got 6 R. If I divide this by R, I get 3. R squared divided by R gives me R. And R divided by R gives me 1. So I have, that's my answer. I don't know what she's trying to show you there, that's retarded. Do you think this is a lot easier to do that way?
Oh, yeah, definitely.
Just, you know, if you want to do it all the time, you can say, okay, there's an R common, and there's an R common. I can just do this, I'll take away, I'll just have like this down here, I'll show you. If you want to do it, if you get really good at it, and you look at it, so minus 18, R squared plus 12R. It's always 6 is common, and so is R. So you can just take the 6 outside right away, and the R right away, and say 18 divided by 6 is going to be negative 3. R divided by R is going to be R, plus 12 divided by 6 is 2, and the R's are gone. You can do it in one step. If you do, but you don't need to do it in one step. You can do it one piece, then the other piece. So that's all. There's no right or wrong way to do it. You still end up with the same answer at the end of the day. Doesn't matter what way you do it. Just choose whichever way easiest way you find it.
It was way easier, though. And that was all I was confused with GCF, too.
Okay.
Well, now I actually understand GCF a lot better than how Mitch was teaching it.
Okay, no worries. If we have 1 nautical mile, it's equal to 1.087 kilometers. And you want to turn nautical miles into kilometers, right? So how many nautical miles do we have? 6. So we have 6 nautical miles. Now what happens, because these two things up here are equal, we can write them one way or another way. I'm going to show you what I mean by that. Move this down here for a second. I can take these here, and I can write them 1, I'm going to change the color, sorry, big on colors. 1 n m over 1.087, which doesn't seem to be right in the order of your answers there. Okay, m, or I can write 1.087 km over 1 nautical mile. Okay? So, but to do this, what's happened, because this is equal to this one, because this one is equal to this one, what happens in math if I have 4 over 4, top and bottom are equal? What is it equal to? 4 divided by 4 is?
Oh, sorry.
Close. 1. Right? So, the number on top is the same as the number on the bottom. If they're equal, the answer is 1. So we said these were equal. So then this here is equal to 1. Okay? So if I multiply 6 nautical miles by 1, I'm going to get 6 nautical miles, right? But since these here are equal to 1 as well, instead of using the 1 down here, I can take one of these and put it down here. See that?
Mm-hmm.
Now I'm multiplying these two numbers together. So I'm taking 6 times 1.85, so it's going to be, so multiply by the top times 1.087 km, all divided by 1 and m. And what happens here, you notice that the n and m, because the top and bottom are the same, they cancel. Right? So what I'm left with, after they cancel, is just 6 times that. In my calculator, I would go 6, turn it on first, 6 times 1.087, and then all of a sudden it changes into kilometers. It would be 6.5. And you just changed units from nautical miles to kilometers.
Okay.
So I have to worry about. And when I go from kilometers to nautical miles, all you got to do, instead of using this one, use this one. See? Like I do.
Alright.
That makes sense. And that's the easiest way you can do conversions like that.
Yeah,
Once you know this part right here, once you have this conversion factor right here, you can go either way. Kilometers and miles. It doesn't matter what it is. It can be like inches and feet, be yards and meters. It can be centimeters and meters. It doesn't matter what it is, as long as you know the equivalent point right here.
Mm-hmm.
Cool. Do you understand that?